So first of all, I'll explain De Morgan's laws. So the first law is A NAND B is equal to not A or not B. Then in the second law is very similar to the first law, but in reverse. So we have A nor B is equal to not A and not B. So here, for this question, complete the truth table for this logic circuit. So we have A and B, and then we have a NOT gate after. So let's first do the working out for the A and B. So 0 and 0 give us 0, 0 and 1 also give us 0, 1 and 0 give us 0, and 1 and 1 for an AND gives us 1. Then for the NOT, we just reverse what we already got from the A and B, which will give us 1, 1, 1, 0. Therefore, that is what we get for X. So the answer is 1, 1, 1, and 0. And for here, we'll do roughly the same steps. So let's first do the NOT A. So reversing A, so we get 1, 1, 0, 0. Then we'll do the same for the NOT B, which gives us 1, 0, 1, 0. Now, for the OR, we do an OR between the NOT A and NOT B, which is the two lines we have in our working space right now. So 1 and 1 give us 1, 1 and 0 also give us 1, 0 and 1 give us 1, and 0 and 0 give us 0. So our final answer for this truth table gives us 1, 1, 1, 0. Now, student decides to write an equation X to represent the full behavior. Write the Boolean expression. So in the first circuit, we have here, we have A and B, then NOT, which is the same as A NAND B. And the way you represent A NAND B is A dot B, and you put a line over to represent the NOT, so A NAND B. And for the second one, we have a NOT A or a NOT B. So it's simple, you do NOT A, so an A with a line over it, or with the plus, NOT B. Now, I'm gonna write the De Morgan's law, which is what I already showed earlier on in the beginning. And so we can just write A NAND B is equal to not A, not B, or not B, sorry, which then shows that circuit 1 and 2 are actually the same. Now, for here in this circuit is similar to circuit 1 and 2. It's kind of a combination of both. So in the top part, we have not A or B. So we can write that like this here. Then we also have and B, but the whole thing is not, so it would be a NAND. So then we represent that by putting a line over the whole thing, because it's NAND of the whole first expression and B. Now here we can simplify this down. So we can first use De Morgan's law, simplify from this step here. And now using De Morgan's law, we can get A and B with a double NOT on top, or NOT B. And the double NOT cancels out, which gives us A or B or not B, which then is the same as A or B or not B. And B or not B is the same as giving us 1. So then we end up simplifying that down to A plus 1. And anything or 1 must also give us 1, so the final answer we get there is 1.